Hey guys, welcome back. We're going to continue on with our lecture material, and this is going to be from section 3.2. This is looking at density. You guys have seen density in physical science, and hopefully you've seen it a little bit in biology, and the principles of density are all around us. But we're going to go over the formula and how water behaves and how different materials behave in different densities. So let's go ahead and get started. So density is often a capital D. That is how we will see it. So this is actually saying the formula for density. So the formula for density is going to be equal to mass over the volume. And so lowercase m is your mass, and uppercase V is going to be our volume. So mass divided by volume. Again, the units for mass that we saw previously from 3.1 is going to be grams. And while volume is measured in liters, a lot of the samples that we're going to be using is measured in milliliters. So those are the units for density. However, if you remember from physical science, hopefully you did this experiment where we have this little box. Here's the little box right here. This box measures about 1 centimeter by 1 centimeter by 1 centimeter. And if we're trying to calculate the volume of this box, we can do so mathematically. So volume is going to be equal to the length times the width times the height. So here's the length, here's the width, here's the height. We multiply those values together, and we get 1 centimeter by 1 centimeter by 1 centimeter. We can calculate the volume of any regular object using this formula here of length times width times height. When we multiply that out, what we get is we multiply the numbers, which is 1 times 1 times 1. We also multiply the units, centimeters times centimeters times centimeters. That doesn't give me 3 centimeters, it gives me centimeters cubed. So what I have in this box is 1 cubic centimeter. But what is the volume of liquid in milliliters that will fill this? Well, I have a little pipette here, and this pipette has exactly 1 milliliter in it. And when I put this liquid into this little cube here, you can see it's almost perfectly fitting on the inside right there. So what that means is that 1 milliliter will fit inside 1 cubic centimeter. That's why I have this over here. 1 milliliter of fluid will fit inside this cube of 1 cubic centimeter. That's why it's also called cubic centimeter, because it's shaped like a cube. So 1 cubic centimeter also has the value of 1 milliliter. And if that's the case, my units for density could also be grams per cubic centimeter. So that is the units for density and the formula for density as well. So let's take a look and see what happens when you increase the temperature for most substances. For example, air. You have a hot air balloon. Okay, hot air. So that's our example. Maybe put this. We have a hot air balloon. What happens to the volume of your hot air balloon? So when we increase the temperature, what happens to my volume? So I increase the temperature. This is then going to increase the volume of the hot air balloon. The balloon begins to expand. So looking at the formula for density, density is equal to mass over volume. So if I am increasing the volume of something, look at what it's doing mathematically. I'm increasing the denominator. Huge principle in mathematics. When you increase this top number of a fraction, it's going to increase your value that you're trying to calculate. However, if you increase this right here, the denominator, it's going to decrease this value. For example, let's say I have a mass of 1, okay, and the volume is going to be, we'll just say 1. Okay, what's my density? My density is 1 over 1. My density would be 1. But let's say my volume increases. So let's increase this to a volume of 2. Let's say the volume doubles. Well, the mass has not changed, but look what has happened to my density. It's gone from 1 to 1/2. What's happened to my density? My density now has decreased. So when you increase the denominator, you're going to decrease your actual value. So let's take a look at how this has an effect on water as well. So water is H2O, and this is going to be our liquid water over here. So let's go ahead and say this is my liquid water, and this is going to be an example of my ice water, or my solid water. So this is showing my H2O has an O. So here's, for example, here's the water particle. The oxygens are the red. The hydrogens are my white portions. Now, liquid water has this shape right here. This is a two-dimensional picture, but this isn't a three-dimensional model of it right here. This is what the water looks like, with the center being surrounded by 4 others. And again, this is the liquid state. And water has a very unique property. There are only 1 or 2 other substances that are known to do this. But what happens is when you freeze ice, ice is going to expand. So when you decrease the temperature, we're going to decrease the temperature here. When we decrease the temperature, this is what happens to the water. It rearranges into this crystalline form that looks like that. So when we increase the temperature, look what has happened on the inside of our water particles. It creates literally this zone of empty space. So it increases the space between the water particles. So when we're close to freezing, the water particles rearrange into this crystalline form, which is your ice, and it's going to therefore increase the volume. Well, let's take a look at the formula now for density. Density is equal to mass over volume. So previously, my volume, when we increase the volume, it's going to decrease the density, and it's the same thing here. When we increase the volume, because my water particles are now expanding to occupy this crystalline structure of this hexagon, I'm going to increase the volume. It's going to decrease the density. Okay? So what happens is, if I take an ice cube and I put it in water, what should the ice cube do? The ice cube should, of course, let's see if you can see this. It's not floating. Why is my ice cube not floating? Okay, let's look at this again. Okay, I increase my volume. I therefore decrease my density. Therefore, ice water is going to expand, and this should explain why ice floats. So ice water floats. Why is it not floating in this? Can you think of an explanation? Well, let's take a look. We'll try to explain it here. So the density of water, let's say I have 8.0 grams of water, and my volume of 8 grams will actually be 8.0 milliliters. So to calculate the density, I take 8 divided by 8. and that will give me 1.0. And what are my units? It's going to be 1.0 grams per milliliter. Well, let's take a look at the density of ice. Well, my 8 grams of water has not changed its mass, so it's 8.0 grams. However, if you remember, when we decrease the temperature, we're now in the ice form, my volume is going to expand. 8 grams actually will approximately expand to 9.0 milliliters. And if you plug this on the calculator, the density is going to be 0.89 grams per milliliter. So density of water is 1. Okay, the density of ice is 0.89. Let's draw a scenario over here and draw 2 scenarios. Scenario 1 and scenario number 2. Okay, here is water. Okay, and again, the density of water is 1.0. My ice should be floating on the top because its density is 0.89. Okay, less dense things are supposed to float. Less dense ice is going to float because the density actually is lower than the 1.0. Just like the hot air balloon. Things that are less dense, hot air balloon floats. Ice is less dense than water. It should float. Well, why did it then sink? Why did it sink down to the bottom of my flask? Well, what must the density of this be if this is actually sinking? Well, the density of this material has to be less than 1.0. It actually needs to be less than 0.89. This material actually is not water. This material is actually rubbing alcohol. The density of rubbing alcohol is 0.80 grams per milliliter. What is my ice compared to the alcohol? The number mathematically is higher compared to this. It therefore has a higher density, and therefore it is going to sink. So because the ice is more dense than the surrounding alcohol, more dense means it's going to sink. So that explains why the ice, sorry about that, why the ice sunk in the alcohol. That's it for today.